Welcome to Podcast as Code, a show about the operations side of the software development lifecycle. I'm Mitchell Scott.
And I'm Gabe Cook.
Today, we're going to talk about securing Kubernetes. But first, let's talk about a current event.
They just posted this one, right?
Yep. Yesterday. Or, Saturday.
Don't date the podcast.
Yeah.
Yeah, they posted this on the 4th. Cloudflare had an outage, and they just posted the postmortem about it. I haven't read over it much yet. I know you did.
Yeah, I read through it today. Back on November 2nd, Cloudflare had a pretty long outage. And it wasn't, like, you probably didn't notice any sites going down. Their routing plane and data plane, as far as I can tell, stayed up, at least for all the services we use from Cloudflare. The issue was with some of their control plane services. And reading through their postmortem, the root cause was a power delivery issue with a utility that provides one of their core data centers. So Cloudflare doesn't own their own data centers, right? They're using a data center called Flexential in Oregon. And so they lease space in this data center. And just from reading through it, I'm guessing that they just lease space and they have their own, like, Cloudflare owned hardware in the data center. So, they rely on the data center for stuff like internet connectivity and power. The data center apparently has like 10 generators and redundant utility connections to different power companies. One of the power companies had some maintenance that happened that took down one of the utility feeds. The data center brought up their generation systems as expected, and for some reason left the other, like the backup utility feed on.
Oh no.
And Cloudflare doesn't have all the details from Flexential yet from the data center. Somehow a ground fault happened, which is never good, but when you're talking about over 12,000 volts of utility feed power, ground faults are really, really bad, and it knocked all the generators offline because of, like, there are very heavy-handed safeties in place for when a ground fault occurs. Like, you get kind of visions of those big utility knife switches that are like arcing and stuff. So everything, all the power systems in the data center went down like hard, to the point that like electricians would have had to go on site to like deal with the safeties that took that stuff offline, which is fine. Like, the fact that most of Cloudflare stuff is fine is because they're not solely relying on this single data center. It's one of a couple they have in a high availability setup.
Yeah, I feel it's actually pretty nice that it's a good look for Cloudflare that no actual workloads went down. Like, the actual sites were fine.
Yeah, so the stuff that went down is kind of, I don't have a list of all the services. We'll post a link in the show notes to Cloudflare's postmortem that they published on this, which is really well done, and I encourage everyone to read it.
Yeah, they have some of my favorite postmortems.
Yeah, it's a really good example of like them walking through the problem, talking about the systems, like, things they did right, things they didn't do well, and steps they're going to take in the future to get to a better place. I like the transparency from Cloudflare. It's really nice to see, especially as some vendors kind of have stopped providing such transparent postmortems.
Yeah, some large cloud vendor where their last write-up is like December 2021. AWS.
Yeah, I agree with you that it's a pretty good look for Cloudflare coming out with this. Like, yeah, not great that some of their workloads were still on a single data center, because like you need to plan, as we talked about in our last episode, like data centers can go down even though they have redundancies, right? Like, at some point an entire building can go down. Like, it's not infeasible.
Yeah. Another thing this article mentions is the analytics service went down. So that's
was a big
little
one.
Frustrating.
That was a big one, I think. Yeah. Analytics and then logs. They have some logging services that, because a lot of their logging systems are apparently on their like perimeter on the edge, those will queue for a long time. And they just determined that losing some log aggregation was an acceptable failure situation. I don't know if they've rethought that. I'd have to go reread it in some more detail.
Yeah, it gets pretty detailed, this one, honestly.
It is. They talk about the whole disaster recovery process. And like, as we talked about last time, as power started to come back, or as the data center was communicating with them about like timelines and things, at one point, like, actual physical circuit breakers had failed. So they were having to order or procure parts to go swap in new circuit breakers. So like the recovery time power up was going to be slow. So Cloudflare did the thing that we talked about last episode where you kind of weigh your recovery options. Like, do I break the glass? And they ended up saying, yeah, we're going to bring up a European data center that we have on, like, it wasn't warm, but they spun that up and got everything powered up over there because the recovery time in the States was going to be longer than they were comfortable with.
Okay, so they mentioned the outage is 11:44 UTC through 17:57, so 5:57 p.m. UTC. So I guess that recovery time was when they swapped to European data center.
Yeah, they didn't get clean power back in Oregon until 22:48 UTC.
Oh wow. Okay. Well, that's cool that they were able to fail over.
And then interestingly, when they, you think about like, oh, the power came back on, all the servers spun up and everything's fine. Not really. They made the call that like it's likely all this hardware had like a bunch of power cycles as the power got dirty and failed. Ooh. So they basically just wiped and restored from scratch all their hardware. Like, I think they use the same hardware, but they like re-provisioned all the boxes in that data center because like they knew that like multiple power cycles might have occurred, which can make some, that can make stuff unhappy.
Yeah, it could cause corruption or something, especially if it lost power during boot multiple times.
Exactly. Yeah, they said their only safe process to recover was a complete bootstrap of the entire facility.
Wow. Well, that's pretty cool.
And rebuilding they finished the rebuild in 3 hours. So that's pretty good.
Pretty solid infrastructure.
Yeah. Actually, I'm sorry. That was the configuration management servers. And then let's see. Each remaining server took between 10 minutes and 2 hours to rebuild.
Still not bad.
Yeah, so I guess they got power back at 22:48. They had all the servers reprovisioned and running back at 4:25 the next morning UTC.
Oh, you're right. That timestamp I saw was most services had come back, but then by 4:25 they had full restoration.
Yep. Not much data loss, apparently. There might have been some analytics workloads that didn't get fully replicated in real time. But yeah, I think on the whole, Cloudflare comes out of this looking pretty good. I mean, they've obviously got some lessons that they learned from this, but in the end, like, you don't learn these lessons unless you take down an entire facility or you have something take it down for you, because you can architect all the high availability and stuff in that you want, but until you actually, pull the plug on an entire data center, you're not totally sure exactly how all your services are going to behave, especially when you have, hundreds or thousands of services like Cloudflare does. And in the end, like a handful of things went down, not, all the Cloudflare sites on the internet stayed up, obviously, because if they didn't, like, everyone would have known about this.
Mm-hmm. Or instead, it's just kind of a quiet write-up they put out, but still very in-depth for not even losing full service. It's really, really refreshing.
Yep.
For sure.
Yep.
So yeah, we'll link to that in the show notes.
Yeah, I would definitely encourage everyone to read through it just as an example of like how you would conduct a postmortem or how you should think about disaster recovery and business continuity planning yourself. Like, Cloudflare had an outage, so maybe you should go review your setup and make sure that, if something happened to your data center or your cloud vendor, would you fall into some of these same traps that they did? Like, would it catch you as well? You could kind of do your own brief postmortem on their outage, but with your infrastructure in place of it as a proxy, just to, try to learn from their mistakes before you have to learn from your own.
Definitely.
Awesome. Let's move on to our main topic, securing Kubernetes. Why do we need to secure Kubernetes? Like, we don't actually have to, right?
I think we do. So there's quite a few layers here that we'll talk through. Securing any service is pretty important. If you have something insecure, it can lead to a site getting exploited where someone can actually run commands in your infrastructure or pull data they shouldn't be able to see, or even just being defaced, like someone changes the homepage to show, this site was hacked by someone. So it's not great. There's a lot of layers to security that we're going to talk through in this episode, and they're all pretty important, especially when running, like user-facing services.
Yeah, so if you're just joining us, we've covered a few topics over previous episodes that you may want to press pause on this one and give those a listen, starting with our main episode on Kubernetes, which was episode 3. We had an episode on monitoring, which was episode 2, and we'll probably be covering some things that that touch on monitoring. And as well, our first episode 1, was on GitOps, and I'm sure we'll talk about some GitOps tools that we use to help implement some of these security features and practices. And I think, like you said, security on Kubernetes is pretty important, especially because Kubernetes really lends itself to being a platform that hosts like multi-tenant workloads. So you could have, in our case, separate customers on the same cluster, which means that...
Yep. And you want to isolate as much as possible.
Yeah. You have a pretty... I don't want to say it's high risk, but it's an elevated risk of, some customer doing something or having a code base that's old and fragile and leaking bad things to another unrelated customer. And then that's really bad for you as the host of that data.
You're right. I mean, security is really kind of like a chain link in that you're only as strong as your weakest link. So it's easy to, deploy your production sites and say, oh yeah, they're really hardened, but then you could have some dev site which isn't secure, or some old service that you've taken on and you don't know what exactly it does. I mean, maybe the high level, but you don't know every line of code.
Right.
And so if that site's vulnerable, all your sites are vulnerable.
Awesome. Let's start like as far out as we can get. And let's talk about the Kube API.
Yeah. So it's kind of going top down. So like at the very top, Kubernetes has a standardized API to manage everything. And I think this section will be pretty quick compared to the actual like lower level networks and container sections. But the Kubernetes API, first of all, some services in Kubernetes will talk to the API, and they use what's called RBAC, or role-based access control. This is stuff like a lot of ingress controllers do, because they need to access the API to find what ingresses you have. They need to know which containers should be routed to the internet and things like that. Other ones are like Cert Manager, and a lot of the Kubernetes, like Core DNS needs to. So these all kind of ship with isolated security. Like Ingress Nginx, for example, probably can't pull everything from Kubernetes. It'll push an RBAC configuration so that it can only fetch the things it needs, like ingresses and the TLS secrets and things like that. And this should be something that it just ships with, but it's good to be aware of. Like if you're deploying a service and you see it creating an RBAC configuration that just gives it everything, maybe take a second and think about why it needs
look for the resources it wants permission to query, and make sure that those are things that you would expect of it. Some stuff will need to read secrets. Other projects you deploy may have no business like getting Kubernetes secrets by themselves.
Yeah, so that's actually something I realized I should have said before now, but while we were kind of typing up these show notes, I realized, so I've created a couple Kubernetes operators for, different use cases, and most of the time they didn't need to be able to pull secrets. I think in our Kubernetes episode, I mentioned you should use secrets because they can optionally be encrypted. But another benefit is some things need to pull the running pod information, but they don't need to pull secrets. So that isolation is really nice.
Yep. So not only does stuff running in the cluster talk to the Kube API, but also like that's how kubectl or K9s or whatever your engineers are using to talk to the cluster. That's also how they talk to Kubernetes, right?
Yeah, or if you use a cloud vendor and they show metrics and logs, I'm sure that's somehow connecting to the API.
So you might think that like, oh, I need to be able to talk to this from my laptop from anywhere in the world, but that's really, really actually quite dangerous. And there have been some exploits, or maybe not exploits. There have been some vulnerabilities to the Kubernetes API when it's publicly exposed.
It's, I think mainly what I've seen has been misconfiguration. If you don't make your control plane public and then you just completely like disable authentication for it, that's not great, but at least it's not public.
Yeah.
But I remember seeing an article where they had found thousands of Kubernetes control planes that were possibly public and unauthenticated, or use some default certificate from a tutorial.
Yep.
So Yeah. That's kind of the first layer. Make sure your control plane or the Kubernetes API isn't public. And usually you want to connect through a VPN or something like that.
It's a pretty tasty target if someone can find it, because it's the keys to your infrastructure. An attacker could potentially have the ability to run arbitrary code or containers or whatever they want in your cluster if they get enough access to it. Or even if they just have enough access to query things, and that's not good either.
And it's a really easy thing to fix. I mean, deploying a VPN isn't necessarily easy, but ideally you have a static IP address your requests come from, or an existing VPN. And if you use any cloud Kubernetes deployment, it's usually an option. Like when you deploy the cluster, it'll have a checkbox that's like, is this a private cluster? And like, what IP addresses can hit the control plane?
Yeah, to me, it's like you really anymore, you don't want servers, like Windows servers you don't want on the internet with RDP open. A Linux box, you don't really want SSH just available from anywhere. Same thing with your Kube API. You don't really want that public. Like that's just it's a big surface to attract attacks.
Definitely. And then I had mentioned kind of the API access, but this is just a quick call out. I think by default, if you use like kubeadm or K3s, the default is to use like an X509 client certificate, or even just like a single certificate. That's fine. But if you use a cloud provider, they'll handle the auth, which is preferred. Typically, I would prefer GCP's Kubernetes engine called GKE. And when you deploy it, it just automatically uses the gcloud command line to authenticate into the cluster, which is really nice. And then self-hosted has a similar strategy, which I haven't used, but I think would be cool to try out. They have OIDC authentication, so you can create a list of users that have access to the cluster, and they log in through some SSO endpoint. So,
certs are a little cumbersome to pass around. I mean, not pass around, but provision your engineers with the right certificates to talk to the cluster. And then also, then you have to deal with, and I assume like K3s and kubeadm support this, but like cert revocation is always a little bit of a pain. So if you can kind of obfuscate away that with OIDC or one of these cloud auth providers, then that's a lot better user experience.
Although at the same time, the reason I haven't messed with it yet is it sounds like it's a scary thing to break.
Yeah.
If I can't hit my Kubernetes API.
That's the same reason I haven't, because like my personal cluster at home, the authentication provider I would use runs in the cluster. So I have a weird bootstrapping problem if like the cluster is broken for some reason. Like, oh, my authentication provider's down, I'll get into the cluster. I can't because it's,
So ideally there's some break glass cert, or maybe you can configure multiple. I definitely like to look into that.
I need to do that as well.
But those are the main things with the actual API. Really, the one that I'd emphasize is just make sure your control plane is private. Even in like a cloud environment or whatever, might as well.
Yeah, and if you're going through any certification process, they'll flag that pretty quickly. Like a public kube API, that'll flag on SOC 2, NIST, all those sort of things, all those audits.
Yeah, conveniently, it's a dangerous thing to do, but it's also very easy to check for. You just get the API IP and see if it's public. So yeah.
All right, so that's kind of limiting cluster access from like the whole world. So let's go in a layer. So now we're inside the cluster. I guess we're on the border of the cluster. So we could talk about like kind of some firewall type things we can get into. So we're going to kind of be pivoting into the networking space a little bit here, right?
Mm-hmm. Yeah, you're right. I mean, there's networks outside of the cluster that route to the cluster, and then there's a network within the cluster, and both are important. So first of all, ideally you have, some external firewall configuration so that anytime you deploy a service, like with node port, you don't actually just get a publicly routable port. There might be use cases where that's desired, but it seems a little dangerous to me. I'd prefer to block those by default and then whitelist as needed.
Yeah, I think in general, the only thing we allow in from any IP address would be 80 and 443.
Typically. I mean, I'm sure there are other viable use cases, but typically the only thing you want to whitelist from the internet at the edge through to Kubernetes to the workloads, it's going to be HTTP ports.
Yeah. And you definitely want to be careful because it's easy to poke those holes while you're in the getting stuff working phase or getting something deployed, and then never go and lock that down to what actually needs them. So it's definitely beneficial quarterly or, however often by policy or just best practice, go and check your firewall rules against your Kubernetes clusters and make sure stuff that should be pretty limited is as limited as it should be. Because we've definitely opened up database ports, not widely, but we've definitely opened up a Postgres port so the client could connect to a service, and then 3 months down the line they didn't need to connect anymore. And then did we go shut that rule down? Realize. Maybe not.
Yeah. Another thing, earlier you mentioned ideally not exposing SSH. A lot of times the cloud Kubernetes nodes do actually have SSH. I personally don't use them. I think Mitchell and I have used them one time when we were having some NFS issue and we wanted to check the system level logs. But if you have a firewall outside the cluster, that's just blocked by default. But that's good practice anywhere. So the next thing, and this is more Kubernetes specific, is network policies. So network policies are a resource in Kubernetes that you can configure. And by default, all your workloads are completely unfirewalled. So if you have multiple namespaces, when you're first learning Kubernetes, you might assume that namespaces are blocked from other namespaces.
Yeah, I definitely did. I definitely assumed that.
Yeah, me too. Yeah, but they're not. Basically, you can do... So if you run two services, if you have an app and Postgres, typically you'll make a service, they're in the same namespace. The app will just talk to a service called Postgres. But if something's in a different namespace, they can just do Postgres dot namespace, and they can talk to that other namespace freely. So network policies let you restrict the communication within the cluster, and you can get very in depth with this. Really, kind of the default policy that I'd probably recommend would be just isolate everything to their namespace. If you haven't, deploy each app in their own namespace, block them to not talk to other namespaces, and then add some exceptions, whatever ingress controller you use probably needs to talk to your app, things like that. Some things like the ingress controller and again cert manager and stuff will need to talk to the Kube API, but overall, kind of limiting to namespace prevents a lot of the issue that I mentioned earlier of you're only as strong as your weakest link.
Yeah, one thing to watch out with network policies, like you mentioned, by default they're permissive, completely permissive. You have unrestricted ingress and egress. As soon as you create any policy, that bit flips, and it's then everything is blocked except for what you explicitly allow. So you may just watch out as you go create your first one in a namespace or whatever. As soon as you do that, all the traffic is going to get blocked except for what you allow. So make sure you have some tooling in place or ways to visualize what containers, what pods are trying to reach what resources, so that you don't get too aggressive with what you're blocking. Because a lot of your things may need access to the internet, and you may say, oh, I'll just lock everything down to the namespace and let stuff in from the ingress controller, and then some service you have needs to go talk to a web API out on the internet somewhere, and it can't. And that is, that's not good. You want your services to work. You want everything to be secure, but you still need everything to communicate with the minimum stuff they need to talk to.
That's true. Maybe the default recommendation should probably be restrict to namespace or public internet. But there's definitely some services where it's nice to air gap.
Yeah. And it'll depend on what you're doing. And then another one to watch out for, another kind of gotcha, would be make sure stuff that I think almost everything needs to talk to kubedns. Stuff, DNS is an important thing to have working.
This isn't a standard Kubernetes feature, at least not yet. I know some of these CNIs are pushing to standardize this. But I've used Calico and Cilium, and both of them have global network policies you can create. And in my personal cluster, that's basically what I've done. I've made a global network policy that's I don't care. Anything can talk to core DNS because I don't really care to block that.
Yeah, we'll add in the show notes. There's a web tool that lets you kind of visualize what a network policy will do, and it'll actually spit out the YAML for a network policy, and I believe also a Cilium network policy.
Yeah, that tool's really nice. It's by the Cilium team, but it works with the standard network policies too. And also, I I feel like I've been really into Cilium lately. I think I pushed for it in a previous episode, but it has a nice service called Hubble, where, Mitchell, you mentioned making sure your services can still talk to the things they need. If you have Hubble, you can pick a namespace and then see everything running, all the communication, and see what was blocked really and what wasn't, which is really helpful. Yeah. I think that network policies were really tedious to set up until I had some sort of UI for that.
Yeah, network policies, they kind of solve the issue they solve part of the issue we were talking about before with the multi-tenancy. They do allow you to kind of pretty completely lock down on things in a namespace or whatever you want. It doesn't have to be namespace specific. You could lock down individual pods if you want with pod label selectors. But kind of our standard practice is put each app in a namespace with its database and other services it needs to run, and then isolate that namespace. So we can run apps running ancient code bases with vulnerabilities in them alongside apps that are, brand new and patched and don't have any vulnerabilities. And we're pretty confident that, like, if that older app gets compromised, it's going to get compromised. Like it's not safe because of a network policy, but the blast radius is limited to just that application. So it gives us more comfort in hosting some things multi-tenant that otherwise we would say, this has to be separate. Like, there's no way we're going to put this on shared infrastructure with other stuff. And that's not an excuse to, like, not patch applications, but, like, realistically, in our case, like, sometimes clients are migrating off of an application. They don't want to pay to update it. In some cases, you may have an application from a vendor, like, that you didn't even write or build, and it's running, old versions of OpenSSL or something. So you don't always get to control, like, how patched an application is, but you can control what other things it can hurt if something bad happens to it.
Yeah, you can control the blast radius.
Yeah, exactly.
Yeah, and I was going to mention too, at my home infrastructure, it's been pretty nice to be able to separate out the apps that I run and my actual LAN, because I don't have a fancy, like, router or firewall or anything. I do like my router, but it's just a consumer router, so it's not really built for all the things I'm using it for. And in the past, I had a pretty beefy VPS, a cloud server I was paying for to run my workloads, because I run a lot of services and I didn't want them to all be able to, like, talk to my MacBook. I mean, recently there was actually an issue with somebody self-hosting services and one got hacked, and it caused a big data breach or something like that. So I really wanted to isolate. Network policies allowed me to shrink that VPS down from, like, $50 a month down to, like, $5 a month. And I moved everything to my house, and then I just restricted all those services to not be able to even, communicate with devices on my LAN. Only devices communicate with this service.
Yeah, if anyone is familiar with the concept of microsegmentation, of like firewall microsegmentation, where you, instead of a firewall just being at your internet to LAN border, you have a lot of different subnets all going through the firewall. This basically extends that down to, like, namespaces and pods. Because at the end of the day, these are like IP tables rules. These are firewall rules you're putting in place between your pods. So you have firewalls, like, between everything. It's like microsegmentation
to the extreme.
To the extreme, to the workload level. Yeah, it's really, really powerful.
And without this, that would be very hard to do. I mean, like, IP tables, I guess you could create separate IP, like, virtual, I can't remember what they're called. And Linux lets you, like, separate out the IP stack running for an app, and you could probably make IP tables rules, but that sounds really hard. I think this is the first time that I've seen this sort of microsegmentation actually make sense and be doable. So yeah, then the next level is the actual running workloads, the container level. And first of all, is just kind of talking about their Kubernetes security context. So, like, what privileges does the running workload need?
Just root, right?
No, ideally not. So sometimes you probably do need root, but there have been, different container breakout scenarios. They're all pretty in depth, but a root user is usually a requirement. So if you have an app that, like, just serves HTTP, maybe needs to load some files off the file system, maybe ping a database, there's not really any reason it needs to run as a root user. So if you can run it as non-root, then all those container breakouts are pretty much solved. And then the next is privileged versus unprivileged. Personally, I don't think I've ever used privilege. I think there's some cluster services that need it, like I think some of the CNIs do, but I've never deployed a service that requires it. Privileged automatically toggles a flag in Kubernetes, which allows privilege escalation, which is like just not a good term. I don't like that term. That sounds scary.
No, it is scary.
Yeah.
So non-root, does that require stuff at the container build time, or is that just at Kubernetes runtime?
It doesn't necessarily. So in Docker files, you can specify a user. You can create the user and specify a user. And if you do that, the Kubernetes will just run under that user. But a lot of projects and services don't do that. But you can have Kubernetes run whatever workload as whatever user you want, even if they don't exist. It's kind of nice for them to exist. But in the past, I've used the nobody user, which maybe isn't what it's intended for, but it's a user that doesn't have any permission out of the box. So you can...
I think that's what the Bitnami charts run as by default.
They probably do. It's kind of taking advantage of the nobody user, which I think is actually made for, I don't remember now, NFS or Samba or something like that. But I like a user called nobody. It sounds like a user that has nothing, like no access. So yeah, even if a container doesn't set that up, you can configure that in your Kubernetes manifest under the security context. Now, some things will need more configuration. For example, Nginx is a little hard to run as non-root, and the benefits of it are kind of diminished versus other apps. Nginx does a bunch of file system things under like the root PIDs directory and things like that. Tries to run under port 80, which sometimes non-root users can't do. And Nginx, after it starts up, it forks as non-root anyways, so there's not as much benefit. But a lot of services will just run and they don't fork and they serve requests. So that's when it's a nice time to try to, get a quick win and make it be non-root. So I mentioned privileges, and that basically gives a bunch of Linux capabilities. And there's a ton of these. Some of them are like net admin. You might need that for VPNs, but there's others. There's tons of Linux capabilities, and ideally you don't give any. Sometimes you might need one or two, and that's okay. That's better than just full privilege, where it can escalate and get whatever Linux capabilities it needs. Like I mentioned, VPNs will pretty much always need net admin, but as long as they don't have full privileged, that's okay. Just something to be aware of. And then you can kind of take this to the extreme too. One that I haven't used too much, but I think would be nice to use for a lot of apps, is you can turn on a read-only root file system, which is always nice. I mean, if you know which directories need to change and which don't, especially for languages like PHP, where if an attacker could get in, edit your PHP scripts,
like upload a script,
exactly, upload a script, and that would actually be served by PHP. It would be really nice to turn on read-only root so that they can't even touch your PHP scripts. It is a little hard to do that sort of thing though, because apps will often write to the /temp directory, or they'll have a data directory or a cache directory, and you have to make sure that you have a volume bind, at least an empty dir for all of these.
Yeah, for that one, you definitely need to know. You have to have some details about like what the application's doing.
Mm-hmm. Where exactly it needs to write, or just do a full test of the app after you turn this on, because you might find that most of the app works, but file uploads don't, because they go to /temp.
Yeah.
Ask me how I know. And then there's sort of more OS integration, which I personally haven't used too much, but Kubernetes does integrate with, like SE Linux. It can set security labels like per pod. You can tie in with AppArmor, which allows you to configure profiles, which will restrict like capabilities of individual programs within a container or a pod. And then it also can tie in with setcomp, which can filter like the system calls a process has. Like I said, I haven't used all of these, but I know like SE Linux, I know is just pretty common in like Red Hat based Linux distros. So instead of fully disabling SE Linux, you can tie into it possibly. But yeah, those are the main configurations within the cluster. There's some more configuration you can do within the security context. We'll link to the Kubernetes docs. They have a lot of these listed as a bullet point at the top, and then they have in-depth docs on everything, which is really nice.
Yeah, this is all the security stuff is kind of a defense in depth, right? So if your API is private, if you've got firewall rules in place, network policies in place, at least a few of these container side mitigations in place, it's going to have to be a really bad vulnerability for you to get bit by something, because you have all these layers, like kind of the Swiss cheese model, right? Like you'd have to get all the holes in the cheese aligned at all these layers for something to happen.
You're right. I guess that's the main reason I'm less experienced with like read-only root file system. I'd really like to have it, but once you get all of these protections in place, at least at the moment, that's been less important.
Yeah, and I think it's one of those where you knock off the like running as a non-root user. Yeah, that's pretty straightforward.
Mm-hmm.
Can it break some stuff? Sure, but like it breaks stuff big. Like you can see it break. Container, like application will just stop running or fail.
Yeah, typically the issue, like I mentioned earlier, is some environments allow this, but by default, Linux doesn't allow non-root users to bind to ports below 1024. So if you have an app that listens to port 80 or 443 or whatever, 22 or, any common port, that might work, but it'll possibly fail. And you'll know immediately the app will fail to start. So yeah.
Yeah, and then you get further down to like the read-only root file system or the SU Linux or something. Like those could probably have more subtle effects, like if you get something wrong in that configuration.
Yes, yeah, definitely.
Cool, so that kind of covers like the running infrastructure bits. Is there anything we can do before we even have to run code?
Yeah, ideally, once everything's running, that there aren't any, at least glaring vulnerabilities. Kind of the first layer of that would be what's called a SAST, which stands for a static application security test. There are a lot of tools for this. They're a lot easier to set up than what I'm going to mention in a minute, which is dynamic application security test. But SAST basically scan through your code and try to find obvious things. Like, are you concatenating strings as SQL statements because that's SQL injection? Like, that's a pretty easy thing to scan for. You don't necessarily need to actually spin up a site to do it.
Yeah, stuff like, I see you have a variable called password that you're setting to a string. Maybe look here.
Maybe reconsider that. Yeah. My personal favorite SAST recently has been CodeQL. It's by GitHub. It's very tightly integrated into GitHub. It's not cheap. They give it free for public repos, like open source repositories, which is nice. But if you have a private repo, I've also used Sonar Source, Sonar Cloud, Sonar Cube quite often. Have used Sneak in the past. Is pretty nice. These are all pretty similar. They're mainly pulling a list of CVEs, a public list of exploits, and searching through your code to try to find something obvious.
Yeah, and these tools can get pretty pricey, like you said, because
yeah.
I think like while the list of CVEs is public, like I think some of the heuristics these tools build to detect things that are going to trip those CVEs those are probably kind of proprietary, like well curated lists of stuff, and that takes a lot of work to curate a big list.
Yeah, and no, you're right. Like, for example, recently I added a new feature to a personal project where it would log something based on user input. And after I pushed that change to like a dev site, CodeQL flagged it and said, hey, just so you know, logging user entered data without sanitizing it could be dangerous. And it actually had crawled through the parameters a few functions deep to determine the input came from the request. So I was pretty impressed.
Yeah, that is impressive.
Yeah, I was kind of sanitizing the input, but it was client side. So I'm glad it caught it because I was able to fix that before I even shipped code anywhere. So yeah, you're right. Like kind of the heuristic analysis. I'm sure there's a lot of special sauce in all of these.
Yeah.
And then the next layer, and this is quite a bit harder, but very nice if you have it running, is, like I mentioned, called a DAST. And that's a service which you typically give it the URL for your website, give it like a username and password, and say, here's how you log in. And not a prod site, by the way. Do a stage site or a dev or something.
Yeah, for a couple reasons.
Yeah, it will actually click through your site and try to break it. It'll find all the text fields and try to execute like SQL injection. It will try to break the cookies. It'll try to do a lot of things, hijack cookies, and then it'll report what it found and give you a really nice list of results.
Yeah, but we've definitely had these types of tools take down, like we run them usually against like a dev or a test site. And we've had them take those sites down because they're hammering them so hard.
Yeah, they do. It also can be annoying because if you use the cloud hosting, I mean, nice/annoying. For example, Cloudflare might detect a bunch of SQL injection coming from an IP and block it, and then your test fails. So you usually have to like notify your vendors that you're going to do a test, and do it against non-prod because you might break your site. NetSparker is a pretty common one. It gives really good list of results, but I think it's pretty steep. There's also stuff like Burp Suite, which is a little more manual. I think OWASP Zap I've used is the only open source DAST that I know of, but it's pretty good. It's better than nothing. The reason a DAST is harder is because you need that dev site. You need a hosted site that you can.
Yeah, it has to be running.
Yeah, you can deploy temporary changes to, try to break it, and then report results. So they're tough, but it's really nice to be able to do.
Yeah, it's something that we have so far not done as part of like a GitHub action pipeline or anything like that. In theory, like there's nothing stopping you from deploying a full site somewhere and running a scan in your pipelines, but that's going to take a while. So you need to be mindful of that blocking a deployment or something. Typically we have SAST will block merges. We'll have the static tool block a merge. But the dynamic scans, we typically run those at an interval. So like quarterly or monthly, whatever, depending on the application. Or
before a large set of changes.
Yeah, like before we launch a prod site for the first time, we'll make sure we have a fresh scan to know like, before this thing gets, out there in the world, we know that it's safe, that it's secure.
Definitely. Yeah. So I'd say definitely investigate SASTs at a minimum, and then consider DAS when possible.
Yeah, and like you said, GitHub has one. GitLab has one that I think there are some stuff they give you for free. I know there's definitely stuff that's locked behind their more paid tiers as well. But definitely check out what like your Forge has built in, if anything.
Yeah, I forgot to put that in the notes, but I'd be curious if GitLab does a similar thing, because GitHub's is, in my opinion, pretty steep pricing wise. But the fact that they give you full functionality for free in public repos is awesome. I use that for all my personal projects. It automatically runs when I push to any branch, and it'll block pull requests just out of the box with no configuration. It just detects what languages you use, and then it uses those scanners on your repo, which is great.
So SAS is covering like actual code base that you've written, right?
Yeah.
It's not doing anything with your dependencies.
Yeah, so there's even more automation here. The first layer, and this is only if you're using GitHub, that I like, and again, kind of in GitHub fashion, they tried to make it very simple to configure, easy to use out of the box. It's called Dependabot. It will detect security vulnerabilities in your dependencies and open PRs when there is one. That's nice. Out of the box, it doesn't catch all dependencies, even though that's configurable. And it also doesn't work for some configuration languages. Like it detects all the dependency files like package.json or whatever language you use, go.mod. But it doesn't work for like Docker files or Kubernetes manifests. So one step further, I really like taking this, is to add a bot called Renovate, which is very configurable to the point of possibly being a little overwhelming. But it'll detect like your Docker files and automatically do updates if you have like from, whatever, Go 1.20 and 1.21 is released, they'll make a PR to upgrade that. And so Renovate's very configurable. You can define your own regular expressions to parse files, and it supports a bunch of different languages out of the box. I kind of use them both. Renovate is very good. It's not quite as powerful as Dependabot with like transitive dependencies. So if a dependency of a dependency has a vulnerability, I've had Renovate find it, but sometimes I've noticed it won't.
Oh,
so it tries to, but I think it might specifically be an issue with the Go dependencies. I think it does for Node.js, but I thought might as well just keep both turned on. They're both free.
Yeah.
The worst case is you'll get 2 PRs and you just close one. So yeah, they're both great tools. Good to know when you have security issues and dependencies. And also just good to know when you're behind, for like Kubernetes versions and things like that.
Yeah, I literally just merged one like 3 seconds ago.
Nice.
And a Renovate PR.
Yeah, for my home, I've tried to attach everything to GitOps. So like even my K3S clusters get automatically upgraded based on a version defined in a file in my GitOps repo. And I set up Renovate to open a PR when K3S releases a new version. So I always know whenever there's an update ready, which is nice.
I thought most of the containers I was running were pretty up to date. And then like I got Renovate configured and had like 25 PRs get open. So
yeah, it overflowed to page 2, didn't it?
Yeah, I got 2 pages for sure. And so obviously I fixed all those, but sometimes, you don't know how bad a shape you're in until you have something like this actually tell you. So it doesn't hurt to deploy some of these things, even just in a trial mode. I know we had tried Sneak at one point. We gave it about a year and then looked at some other tools that were a little bit more affordable. Cause like we said, some of the stuff gets expensive, but if you see a trial for one of these, you might kick the tires and see tell me what you think is wrong with my code base or my infrastructure, because until you have something take a look, you may assume that things are a lot more fine than they are.
You're right. That's true. Another thing about Renovate I should mention is that it's not specific to any Git provider. Renovate works just fine with Cloud GitLab. Yeah. It doesn't work with self-hosted GitLab with their cloud instance, but it's open source, so you can host it yourself in a CI job, or you can deploy it to Kubernetes and point it at your GitLab self-hosted server, or it works with Gitty. It works with really anything, which is really nice. So Dependabot, you'll be limited to GitHub, but Renovate, works it anywhere.
Yeah, and GitLab does have a dependency scanner.
Oh, do they? Well, one that opens PRs, or is it more like just alerts?
I think it's just alerts. At least the way I've had it configured for a project is just alerts. And they give you like a dependency dashboard, which is kind of cool. Like it'll show you the dependency tree, but I don't know if it opens PRs. Not
it's
totally
still
sure.
Nice though.
Yeah.
Still something to be aware
Still gives you the visibility. Yeah.
Yeah. If Renovate is overwhelming and that one is just like a box you can check, then I'd say go for that first and just see if you have any big alerts pop up.
Yeah. Anything's better than nothing for sure.
Definitely. But yeah, remember, you're only as strong as your weakest link. That's like the TLDR, I guess. But I think that's the main points that I wanted to cover. I think it's even kind of important to, maybe I should have flipped the order. Maybe Kube API should have been first and then container and then networking. But yeah, all these are kind of important facets for sure.
Yeah. I mean, we've definitely worked our way kind of from the outside in as far as, from the whole internet to what's running in your cluster to what's running in your containers to, container, like how your containers are running to what's running inside them. So it's, security is an onion.
Yeah. We just talked about all those layers.
And I didn't cry, did you?
Maybe. Hopefully I muted when I was crying. Cool. Let's outro.
Thanks for listening. Our website is podcastascode.show. If you would like to suggest topics for us to cover or have feedback on topics we have covered, send us an email. Our address is contact@podcastascode.show, or you can hit us up in our Discord. Join us in a fortnight to discuss serverless, function as a service, and how to pronounce Knative.
/native. I don't know yet. We'll see in a few weeks. See you guys next time.